Okay, Assalamualaikum and salam sejahtera. My name is Cikgu Muhammad. So to calculate the enthalpy change, we also can calculate from the standard enthalpy change of formations. And the second method, we also can calculate the enthalpy change from enthalpy change of combustion. Okay, so what is mean by standard enthalpy change of formations? Again, standard enthalpy change of formation is heat change when 1 mole of compound is formed from its elements in their standard state under standard condition, which is 100 kilopascal and 298 Kelvin. Okay, so what is mean by standard state? Standard state is the physical state which is solid, liquid and gas at the standard condition. And what is standard condition? Standard condition is when the temperature is 298 Kelvin and pressure is 100 kilopascal. Okay, so how to identify which equation have standard enthalpy change of formation. So if you refer on the name formations, meaning that any chemical reaction that form a product is called have a standard enthalpy change of formation. Okay, example formation of methane. Okay, so carbon react with hydrogen gas and produce methane. Okay, and then balance the equations. Okay, if we look at this chemical reactions, this chemical reaction form only one product, which is methane. Okay, so the enthalpy change, the standard enthalpy change, also called standard enthalpy change of formations for methane. For methane. Okay. All right. The enthalpy change that involve the formation compound, also known as enthalpy change of formation of the substance form. This is example one. We have the formation of CH4, which is methane. Okay, this is example chemical equations for methane. But as a student, you have to know how to write the chemical formation equation for substance. Okay, the step is first please list down all the elements contained on the compound. Methane have one element of carbon and you have one hydrogen element, meaning that methane have two reactants. Okay, reactant C. Okay, at standard state or for the standard condition, carbon exists as graphite. So the physical state is solid and it reacts with hydrogen. So we cannot write H only. So because hydrogen at standard condition exists as gas, so H2 and produce CH4. So methane also gas at standard conditions. When carbon react with hydrogen, also it produce, of course, it has heat of reaction, or we call standard enthalpy change. For this standard enthalpy change, if it involves the formation of compound, it also called standard enthalpy change of formations for methane. Okay, all right. Okay, let's look at the example two, which is the formation of ethanol. Okay, so ethanol have three elements, which is carbon, hydrogen, and oxygen. So ethanol have three reactants. Have three reactants. And then at standard condition, carbon exists as solid, and then it react with hydrogen gas, and it react with oxygen gas. Okay, so we cannot write O because oxygen is gas at standard condition. Okay, and the product is ethanol, C2H12. H5O H, and balance the equation 2, 3, and 1 over 2. Okay. And in this from this chemical reaction, of course it have standard enthalpy change. Okay, so if the equations are about the formation of ethanol, it also called as standard enthalpy change of formation for ethanol, C2H5OH. But please take note, okay, it must form only 1 mole of compound. Must form uh, 1 mole of compound. If I write the chemical equation of 4C plus 6H2 gas plus O2 gas plus 2C2H5OH. This is not considered as standard enthalpy change of formation. Okay, why? Because this is not 1 mole of compound. Okay, it must form 1 mole of compound. Okay, not form 1 mole of compound. So it not considered as standard enthalpy change of formations. So you have to modify your chemical equations to form 1 mole of compound. Okay. Uh, all right. So the above equation is standard enthalpy change of formation, and the second equation is not. Okay. Next, what is the formula? Okay, to calculate the standard enthalpy change, okay, we also can calculate it from the standard enthalpy change of formations. Okay, what is the formula to calculate the standard enthalpy change? Okay, the formula is standard enthalpy change equal to sum of standard enthalpy change formation for product minus some standard enthalpy change formation for reactant. Okay, so there are two rules. Okay, first you must find the standard enthalpy change of formation from your data booklet page. So actually, most of standard enthalpy change of formation are already write down on data booklet page 12. Okay, and please remember that the standard enthalpy change formation for elements is 0. So, who is element? Element is any atom, and elements also any molecule. Molecule, okay, that made up from same atom. Okay, example O2. O2 is elements. Okay, hydrogen is elements. Cl2 is elements. Nitrogen gas is elements because they are made up from only same type of atom. Okay, so this is another example how to calculate the standard enthalpy change. Okay, so based on these equations, okay, propane react with oxygens, produce 3 carbon dioxide and produce 4 water molecule. And what is the standard enthalpy change of combustion? Okay, don't get confused. Okay, standard enthalpy change of combustion here is also non-standard enthalpy change of reaction. Why I said standard enthalpy change of combustion? Because it involves the combustion process. This is combustion process. So the standard enthalpy change also called the standard enthalpy change of combustion. Okay. So, how to find the standard enthalpy change from the standard enthalpy change of formation? Okay, first step, list this down. The standard enthalpy change for each compound. First, sum of standard enthalpy change of formation for product is okay 3 negative 394. Okay, make sure that on your calculation including the coefficient number, and the answer is negative 2326. And the sum of standard enthalpy change of rectangle negative 105 plus 0. Okay, enthalpy change formation of oxygen gas is 0 because oxygen is elements. Okay, this is second step. So the third step, equal to negative 2326 minus negative 105, and the final answer is negative 2221 kilojoule per mole. So if the question asks, okay, write down in three significant figure, just convert into scientific notation. Okay, let's see. This is three significant figure. Okay, the another method to calculate the standard enthalpy change is from the standard enthalpy change of combustion. Okay, the symbol is delta H C. Okay, so what is standard enthalpy change of combustions? First, we must understand what is meant by combustion. So from the definitions, okay, standard enthalpy change of combustion is heat change when 1 mole of substance burn completely in excess oxygen under standard condition of 100 kilopascal and 298 Kelvin. So any chemical equation that involve combustion also called standard enthalpy change of combustion. Okay, so if you have substance and the substance undergoes combustions with the presence of oxygen and produce carbon dioxide and water. Okay, it has standard enthalpy change, and this standard enthalpy change also known as standard enthalpy change of combustion because it involves combustion. Okay, this is another example of chemical equation that involve the combustion. This is combustion of ethane. So ethane react with oxygen gas and produce 2 molecule carbon dioxide and 3 molecule of water. And the standard enthalpy change of combustion is negative 561 kilojoule per mole. Make sure it have negative sign and have the unit because this is exothermic. Okay. Okay, the formula to calculate the standard enthalpy change from standard enthalpy change of combustion is standard enthalpy change equal to sum of standard enthalpy change of combustion for reactant minus standard enthalpy change of combustion for products. And it have two rules. First, find the standard enthalpy change of combustions on data booklet page 13. And then standard enthalpy change of combustion for oxygen, H2O and carbon dioxide is 0. Okay, why oxygen is 0? Because oxygen is just support the combustion. Okay, oxygen not undergoes combustion, but it just support the combustion, and H2O and carbon dioxide is the product of combustion. So they are not undergoes combustion process. Okay, only substance that undergoes combustion have the standard enthalpy change of combustion. Okay, other than that, there is no standard enthalpy change of combustion. Okay, so how to calculate the standard enthalpy change of reactions or standard enthalpy change? Okay, from the standard enthalpy change of combustion. Okay, here first, please list down all the possibilities standard enthalpy change of combustion, and please refer your data booklet. Okay, for ethene, it have 1411, hydrogen negative 286, ethane negative 1561. And then use the formula. Formula is sum of standard enthalpy change of combustion for reactant minus sum of standard enthalpy change of combustion for product, negative 1411. Okay, plus negative 286 minus negative 1561. So the final answer is negative 136 kilojoule per mole. Okay, so that's all the calculation of standard enthalpy change from standard enthalpy change of formation and standard enthalpy change of combustion. Thank you.